Yo, Xinthaspace here, and I am back with another epic math video. And I will be testing out my brand new intro and outro. And and I will be showing what does I to the I equal. So first thing, this is very complicated. So, we have to first start off with something. So, e to the x equals 1 over plus x plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial plus x to the 5th over 5 factorial. Well, and on and on and on. Now, e to the I x equals, this is the same as x to the 0 over 0 factorial. That equals 1. But, it's just, I thought I'd point that out. And x equals x to the 1 over 1 factorial. So first we have 1 plus I x. Now we're instead going to subtract x squared over 2 factorial. And then subtract I x cubed over 3 factorial. And then add, I think it's x to the 4th over 4 factorial, and then add x to the 5th over, ix to the 5th over 5 factorial. Now, if we rearrange this, we say e to the I x equals, so 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial plus, we're going to factor out the I here. So no i's. X, whoa, that's not an x. X minus I, no I, x cubed over 3 factorial plus, oh my gosh, almost forgot the dot there. That's very important. Plus x to the 5th over 5 factorial. Now, if you don't understand this step, so basically we're subtracting x squared over 2 factorial because this equals I times x squared equals I squared times x squared equals negative 1 times x squared equals negative x squared, which is why we're subtracting here. Same thing here, only I cubed is negative I, and thus we're subtracting ix. So basically the way doing powers of I work is that, so I to the 0 equals 1, I to the 1 equals I squared equals negative 1 I cubed equals negative I, because that's negative 1 times I. Then it goes on and on and on. That whole pattern repeats. And now, you might actually recognize this, and you might notice that this is e to the I x equals, you might recognize these bits. Well, this is actually equal to cosine x plus sine. I mean, it's I sine x, which this actually has a lot to do with something called polar coordinates. So what we usually use as coordinates are what are called Cartesian coordinates. So Cartesian. So the way it works is we have two axes, and you basically can go in the x direction or in the y direction. We use x, y. And we also have another way of doing it, polar, where instead of giving the x direction and the y direction, you instead give out the distance from the origin, which I'll represent with these circles, and you represent the angle, which I'll represent with these lines. And instead of x, y, you give an r value and a theta value. Now, to convert from Cartesian to polar, use, well, x plus I, y. Now, to convert from polar to complex numbers, you simply use, well, x is actually equal to r cosine theta in polar coordinates plus I r sine theta. Now this, well, if we factor out the r, we get, well, this equals r times cosine theta plus I sine theta. If we use this bit from above, this equals r e to the I theta. And now we're going to get to the real bits. So now the polar coordinates for I is actually 1 pi over 2. Well, radians, not degrees. In degrees it would be 90 degrees, but in math we usually use radians. So what this means, I, using this, we get 1 pi over 2, so this is equal to 1 e to the I pi over 2, which just equals e to the I pi over 2. Now this means the natural log of I equals natural log of e to the I pi over 2 equals I pi over 2. And then we get to the bit over here. Now I to the I equals e to the natural log of I to the I. So, which this equals e to the I natural log of I equals, well, that's a really weird equal sign, but I'll leave it. E to the I pi over 2. By definition, I squared, which we're doing here, equals negative 1, so that basically becomes a negative, and we get e to the negative pi over 2. And then we get something really unexpected. I to the I equals e to the negative pi over 2. Not times, Well, my computer fell asleep. Well, I mean, equals e to the negative pi over 2. By the way, I forgot to mention this whole e to the ix equals cosine x plus I sine x thing. That's called Euler's formula. But, I mean, for my last video where Quick Xbox reacts to my mountain, he suggested the intro. I hope you enjoyed this video. Go create. Bye. But I guess it's go solve. Bye. I love making jokes.